Thank you, viewers. In math last time we talked about how to calculate the turning points, that is the maximum and the minimum turning point, the point of inflection, and we also looked at how to curve sketch. That were our last lessons in mathematics last time. In differentiation, we are approaching the end of this chapter, and we are going to talk about applications of differentiation. And the application of differentiation, today we want to look at how to apply the concepts we have learned in differentiation, in kinematics, and also in mensuration. In this our case of today, we want to talk about application of differentiation in kinematics. And we know kinematics, as mentioned here, relates to moving object, motion. Any object in motion is said to be associated with the concept of kinematics. Now, we can use differentiation to be able to determine velocity and acceleration of this moving object. We know that if you have a sketch, and we learned this in Form 2, that velocity time graphs, if this is displacement S time graphs, if you look at if that's the movement, the curve showing the movement, this gradient of this particular curve or graph is going to be, this one is change in S, or change in displacement, this is change in time. So if we take that, getting the gradient of this curve here will be the same as m is equals to ds dt. Now we know that ds in this case, if we use differentiation. Now if we have a graph here, we know that the gradient of a moving change, if it's a change in s or the change in t, is the same thing. That's what we use to get displacement or velocity using a displacement time graphs. Now, in our case in differentiation, we know that we don't have to have graphs every time. We can have, for example, if we have a displacement s is equals to 4t cubed minus 16t plus 3. Every time s, letter s in this particular concept here relates to displacement, and t is our time, where s is displacement and t is our time. So velocity in this case will be the gradient of the curve of displacement time graph. And in this case, our displacement time curve is this, the function is this. So for us to get the gradient ds dt, we have to differentiate the displacement function, meaning that velocity v equals to ds dt, which is the same as, if we differentiate this, will be, we bring 3 here, it's 12 t, 3 minus 1 is 2, minus 16. This is our velocity function. So it means that after getting velocity function, if we know the value of t, we can then be able to get the actual velocity. For example, if t is 1, after 1 second, we can say velocity will be 12 in bracket into 1, which is 12 minus 16, which will be actually negative 4. So once we get the velocity function, getting the actual velocity is not hard if we know the value of t, which is time. So after knowing that, and after dealing with that one, we can move forward now to look at the points to note. If the velocity is 0, velocity 0 normally refers to an object that is not moving, an object that is at rest. So velocity equals to 0 is when an object is at rest. Velocity is greater than 0, meaning a velocity is a positive number, positive 1, positive 2, positive 3, positive a half. It means that the object is moving, the object is in motion. That is when the velocity is more than 0 and a positive number. When velocity is less than 0, meaning a negative number, it means the object is moving, yes, but is moving in the opposite direction. For example, if the object was moving here and velocity is 3, if the object moves in the same direction, the same distance or displacement, but the opposite direction, it will be negative 3. So a negative velocity refers to an object moving in opposite direction. And I said these are very key points that we are going to use when we are calculating velocity. Now, viewers, I want us now to have an example to be able to see, in a case of velocity, how do we handle this issue. So the example I want to use to explain the concept is this. Example, find a velocity when t equals to 3 seconds. T equals to 3 seconds. So we want to know the velocity of this particle when at t equals to 3 seconds. So we don't care before, maybe when the t was 1, t was 2, but we just want to know at t equals to 3, what is the velocity. So we know that getting velocity is the same as differentiating the displacement function, which is ds dt. ds dt in this case will be, we differentiate this, will be 6t squared plus 8t minus 8. This is our velocity function. So we are going to say v equals to 6t squared plus 8t minus 8. Now that we have the velocity function, we need to get the velocity when time is equals to 3. So let me substitute 3 here. So v will be 6 into 3 squared plus 8 into 3 minus 8. So v here, when you are getting this function here, we know that it should be 6 into 3 squared plus 8 into 3 minus 8. That is giving us 70. So we know that now velocity is 70 meters per second. So the velocity at t equals to 3 is 70 meters per second. Question B under that is the time when the particle is at rest. When the particle is at rest. When the particle is at rest. I told you when the particle is momentarily the particle is momentarily at rest. We said that earlier when I was giving you the notes on this particular idea, we are generating the concept, we said when a particle is at rest, then the velocity is 0. So it means that if this particle was going to be there at the time when it's at rest, this velocity function, we are going to equate it to 0, so that we get 6. We know that, let me say, at rest, v equals to 0. Yes. So let's say v equals to 0, that means 6t squared plus 8t minus 8 equals 0. So if you have that one there, let me therefore solve. To solve this one, we can, let me simplify this one. This is divided by 2, divided by 2, divided by 2, divided by 2. I'll get 3t squared plus 4t minus 4 equals to 0. So if I want to solve this thing by using factorization, I will say the product is minus 12 and the sum is 4. Two numbers that if I multiply I get negative 12, if I add I get 4. So that one should be 6 and 2. Yes, so 6, negative 2. 6, negative 2, good. It will be the same. So 3t squared plus 2t minus 6t minus 4 equals 0. Group these two. This is t into 3t minus plus 2, then minus the common here is 2 into 3t plus 2 equals to 0. So we can say then in this case t minus 2 into 3t plus 2 equals to 0. And that one will be t equals to 2 or t equals to negative 2 over 3. So we have got the two times, but you realize that time can never be negative. So we are simply going to ignore t equals to negative 2 over 3 because time cannot be negative. So we are going to say the particle will be at rest at t equals to 2 seconds. So meaning that after exactly 2 seconds of this particle moving, it will be at rest momentarily. It means it will be at rest just in a fraction of a second, then it starts moving again. For example, if you move this, you throw this calculator up, there's a point when it stops just momentarily and then it starts coming down. That's what we refer to as that one as the word momentarily. Stops just in a fraction of a second, then it starts moving again. So viewers, in this case, we have learned an idea here. We have said that you can be asked a question to find velocity when t equals to 3. That is very simple. First, differentiate the displacement function to get the velocity function, then substitute the value of 3 in the velocity function. In this case, we got 70 meters per second squared. And then later on, we are asked to get the time when the particle is momentarily at rest. And I said, at rest, v equals to 0. So we took the velocity function and we equated to 0, and then we are able to solve, and we have found that actually time, the particle is momentarily at rest after 2 seconds. At the second second, that is when we are going to have the particle being momentarily at rest. Okay, now when we come to acceleration, we say is the measure of rate of change of velocity with time. Now, acceleration usually is used to measure whether an object is moving at an increasing speed or at a decreasing speed. For example, if a car at point A is 30 meters per second, and then at point B 60 meters per second, it means that this object has increased its velocity from 30 to 60. So it means that from point A to point B, this object has accelerated. Now, what about if it is moving from point B to A? Where at B it was 60 meters per second, at A it is 30 meters per second, then it means that this object has decelerated because the velocity has decreased. Now, when we are getting acceleration, we need the velocity function first. The velocity function, in this case, we are saying the velocity function is 6t squared plus 8t minus 8. For us to be able to get acceleration from this case here, we have to differentiate the velocity function with respect to time. It means that if a equals to dv dt, so dv dt, we differentiate, this is 12t plus 8. This is going to be the acceleration function, which is a equals to 12t plus 8. Now, once we have the acceleration function, it means that you can be able to get acceleration at any point. If maybe after 2 seconds, you can substitute 2 here, so that you have 24 plus 8. That means you are getting actual acceleration when you know the value of t. But let us find out some of the points that you need to know when you are going to be calculating these particular accelerations. The first thing is that acceleration is equals to 0 when the velocity is maximum. At maximum velocity, an object normally moves at a constant speed or at a constant velocity, meaning that the speed is constant. For example, if the object is moving from point A to point B at 30 meters per second, it means that the velocity is constant across. That is what we refer to when the acceleration is 0. Don't assume that we say that when v is 0, the object is at rest. But when a is 0, the object is moving, but the speed is constant, or the velocity is constant. The second point is that when acceleration is more than 0, a greater than 0, then the object is accelerating, meaning the object is moving with an increasing speed, meaning it's moving and the acceleration is also changing and in an increasing way. In the case here, 30 meters per second, but at B 60 meters per second. It means the object is moving, yes, but the speed has changed, has increased from 30 meters per second to 60 meters per second. So that's what you get when the acceleration is more than 0, meaning 1, 2, 3, 4 positive values, then it is accelerating. On the other side, when the acceleration is less than 0, a is less than 0, then the object is decelerating. Decelerating, it means that it's moving, but the velocity is decreasing. For example, if you have 100 meters per second here, and then here you have 70 meters per second. So it means that this object here has decelerated from 100 meters per second to 70 meters per second. That's what a negative A refers to. So viewers, let us get to an example. So the question is a particle moves in a straight line such that its velocity is meters per second, velocity v meters per second after t seconds is given by v equals to 3 plus 10t minus 10 squared. Find the acceleration at t equals to 3 seconds. The first thing we said that to get acceleration from v velocity function, we saw a equals to dv dt. So that will be 10 minus 2t. That is our acceleration function. So once we know that this is the acceleration function, but we know the value of t, so meaning we are simply going to substitute the value of t where t is in this function. That is going to be a equals to 10 minus 2 into 3. That will be a equals to 10 minus 6, which is 4 meters per second squared. That's the unit for acceleration. Then part B, we are told to find the time taken for the particle to attain maximum velocity. And I said at v max, at maximum velocity, acceleration is 0. At maximum velocity, a equals to 0. So it means that I'll take this velocity function, which is a equals to 10 minus 2t, and equate it to 0. So I'll say 10 equals to 2t over 2 over 2. T equals to 5 seconds. So it means that the particle is maximum velocity attains maximum velocity at t equals to 5. Sometimes we can even be able to now calculate that maximum velocity. And we can say that v maximum will be, the velocity function is here, which is 3 minus 10t minus t squared. So we say this is 3, this is plus, yes. So 3 plus 10 into 5 minus 5 squared. So this is 3 plus 50 minus 25. So we have 53 minus 25, that would probably 28 meters per second. This is the maximum velocity that is attained by that particular object. Let's go to example 3, which is now combining the two concepts, the concepts of velocity and acceleration. And this example is our example 3, and it says a particle or a fixed point is s equals to 4t minus 2t squared minus 5t cubed. Then the equation we are dealing with A, part A, Roman 1, or part A, it's fine. Roman 1, velocity at t equals to 3 seconds. So if this is the question we are asked to get the velocity at t is equals to 3 seconds, this idea we have really seen it before. So what the first thing we have to do, this is a displacement function. This displays like the distance, but we need to get the velocity. Velocity function, we said is ds dt. So ds dt, this will be 4 minus 4t squared minus 15t, 4t, 15t squared. Yes. So, and if this is our v, we need to substitute 3. So it plus will be 4 minus 4 into 3 minus 15 into 3 squared. So v here will be, let's find out, that is 4 minus 4 into 3 minus 15 into 3 squared. That is negative 143 meters per second. That is that question. Part B of the question is part B of the question is time when the particle is instantaneously at rest. Time when the particle is instantaneously at rest. So the instant when the particle is at rest, meaning when the particle is not moving, and we know that at rest v equals to 0. That's what we know. So let's take the velocity function which is here and equate it to 0. That will going to be 4 minus 4t minus 15t squared equals 0. That's that point. So let us see. What about if I take everything the other side? I'll say this will be 15t squared plus 4t minus 4 equals to 0. So the product and sum, the product here is 15 times 4 is 60, and then so 60 product minus 60, and sum is positive 4. Could we have the product of numbers? Or 60 here could be 10 times 6. Yes, could possibly that. So this is plus 60 minus 6. So that is going to give us negative 60. So we'll say 15t squared plus 6t minus 6t minus 4 equals to 0. So this bracket will be, I'll take 5t into 3t minus plus 2 minus 2 here, 2 into 3t plus 2 equals to 0. So 5t minus plus 2, no, minus 2 into 3t plus 2 equals to 0. So here we can say t will be 2 over 5, or t equals negative 2 over 3. But like I said before, time cannot be negative. So it means that time will be t equals to 2 over 5. 2 over 5, 2 divided by 5 should be around 0.4 or 0.4 seconds. So we can say that the particle will be instantaneously or momentarily at rest after 0.4 seconds. That is what we have there. Let us go to, this was supposed to be Roman 2, so let us go to part B of this question. Part B of the question is, acceleration. Find Roman 1, the acceleration at t equals to 2 seconds. Acceleration at t equals 2 seconds. Now at t equals 2 seconds, we know that this, the velocity function, is here. That is v equals to 4 minus 4t minus 15t squared. That is the velocity function. But we know a equals to dv dt, which is going to be negative 4 minus 30t. That is our velocity acceleration function now. So we know that when we know acceleration function, which is a equals to negative 4 minus 30t, then we know that at t equals to 2, so we substitute 2 here, that will be a equals negative 4 minus 30 into 2. That will be a equals negative 4 minus 60, which is going to be a equals to negative 64 meters per second squared. So it means that this, at time equals to 2 seconds, the particle is moving at a decelerating velocity. And then Roman 2 of this question is time taken for the particle to reach maximum velocity, and then calculate this maximum velocity. Calculate this maximum velocity. So viewers, we have a question to deal with there. The question is find the time taken for the particle to reach maximum velocity and then calculate this maximum velocity. One thing we have to know is that we have been able to get our acceleration function. And I said that V maximum at maximum velocity, at maximum velocity, A equals to 0. So it means that if we have velocity function here, which is A equals to that, A equals to -4 minus 30 t. This one equals to 0 at maximum velocity. So we say that that will be therefore 30 -30 equals to 4. If we take that on the other side, so it means over -30 over -30 t equals to 4 divided by -30. That is -2 over 15. Now viewers have an issue with that question because time can never be negative. So it means that this question that we set there was not going to bring in the idea that we need to really explain, because we expect t to be positive. Then when t is positive, we can be able to take that value of t, we substitute in the velocity function to be able to get the actual value of maximum velocity. But the idea is taken home that at maximum velocity, acceleration is 0. So when acceleration is 0, we equate the acceleration function to 0, we get the value of t. That is the time when acceleration is velocity is maximum. Take that value of t, substitute in the velocity function to be able to get the maximum velocity. Thank you viewers for paying attention to us. That is the end of this concept of application of velocity in kinematics. Thank you.